We are now going to be talking about functions. And so we're going to start by going back to section 3.6, which is an introduction to functions. So here's where we talk about what are functions anyway? What are some of the basic concepts involved with functions? And then we'll come back forward to chapter 8 and talk some more about functions. So in math, a function is basically where you have two things where one of those things depends on the other thing. So for example, if you work at a job where you get paid by the hour, the amount of money you earn is going to be a function of the number of hours you work. How much do you get paid? Well, depends on how many hours you work that pay period. Now, that's not the only way this could work. If you worked in sales, for example, then the amount of money you earn might be a function of how much you sell. But in this example, the amount of money you earn is a function of the number of hours you work. So maybe one week you worked 20 hours and you earned $225. Then the next week you worked 13 hours and you earned $146.25. Then you worked 27 hours the next week and earned $303.75. Then you worked 16 hours and earned $180. Then you worked 26 hours and you earned $292.50. But the amount you earned depended on how many hours you worked. Now, there's different ways we could describe a function. One way is by giving a table of values. Like, here's a bunch of different numbers for the number of hours you worked, and then for each one of those, here's the dollars earned that goes with that number. But that makes up a bunch of pairs of numbers, so we can also think of a function as a set of ordered pairs. Ordered because the order matters. It matters which one is the first number and which one is the second number in each pair. So the way I've got this set up, we've got 5 pairs of numbers here, a set of 5 ordered pairs, where the first number in each pair is how many hours, and the second number is how many dollars goes with that number of hours. And since an ordered pair you can think of as like an x coordinate and a y coordinate, and you can plot the point on a graph that corresponds to that x and y coordinate, you can think of a set of ordered pairs as corresponding to a set of points. So that's another way to think of a function. A function is made up of a set of points in the plane. Now, that doesn't mean that every set of points or every set of ordered pairs counts as a function. Here's an example of one that does not. This is not a function. In this example, the number of the dollars earned is not a function of the hours worked. Can you see why not? Well, it's because we have this here that says when you work 20 hours, you earn $225. And then here, this says when you worked 20 hours, you earned $192.50. So if you worked the same number of hours, but got paid a different amount, then the amount you got paid can't depend on just the number of hours you worked. There's got to be something else involved. So in order for dollars to be a function of hours, then for a specific number of hours, there's got to be one specific dollar amount that goes with that. There can't be more than one different dollar amount for the same number of hours. And that means there can't be more than one pair of numbers with the same first element, with the same x coordinate but different y coordinates. And that means that you can't have more than one point with the same x coordinate. you can't have two different points that are directly above one another, because that would mean that they have the same x coordinate, but different y coordinates. So a relation is any set of ordered pairs. A function is a relation, that is a set of ordered pairs, in which no two ordered pairs have the same first coordinates. So here is a set of 5 ordered pairs. It is a relation, but is it a function? Well, what do we have to check? We have to make sure that no two of these 5 ordered pairs have the same first coordinate. And yes, that's true. This is a function. Now, there are a couple ordered pairs that have the same second coordinate, but that's okay. It still counts as a function. Now, what about this second set of ordered pairs? Is this a function? Well, look here. We've got 2 of these pairs that both start with 2. They have the same first coordinate, but different second coordinates, so no, this is not a function. And when you're looking at a graph and trying to decide whether it counts as a function or not, the way you can tell is by using the vertical line test. So that says if any vertical line, any straight up and down line, intersects a graph at more than one point, the graph does not represent a function. If no such line exists, the graph does represent a function. So something like this is a function. Something like this is not a function, because if you drew a vertical line right here, there would be 2 points on that line. Let's look at some other examples. We have to decide function or not a function. So with this graph, any vertical line, no matter where you draw it, is never going to intersect the graph at more than one point. So yes, this is a function. What about this one? Does this pass the vertical line test? Yes, every vertical line would only touch this graph at one point, so yes, this is a function. What about this graph? Well, here's an example of a vertical line that touches the graph at 2 different points. So no, this is not a function. What about this one? Is it a function or not? Yes, it is a function. What about this one? Is this a function or not? No, it's not a function, because some vertical lines touch the graph at more than one point. Maybe 2, maybe more than 2. But for it to be a function, any vertical line could only touch the graph in, at most, one place. And what about this one? Yes, that is a function. Now, going back to our example where dollars earned is a function of or depends on hours worked. The thing that depends on something else is often referred to as the dependent variable. And then the other thing, the thing that it depends on, is called the independent variable. So we usually put the independent variable first as the x coordinate and the dependent variable second as the y coordinate. So in this example, hours worked is the independent variable. That's the first number in each pair. And dollars earned is the dependent variable. That's the second number in each pair. So we're thinking of dollars earned as depending on hours worked. The dependent variable depends on the independent variable. Some terminology here, 2 words that you need to know: domain and range. The domain of a function means the set of all possible values of the independent variable. Everything that x, or the first number of the ordered pairs, can be. And the range of a function refers to the set of all values of the dependent variable, the set of everything that y, or the second number of the ordered pairs, can be. So in the example we were looking at here, if we have just these 5 points, just these 5 pairs of numbers, the domain would be the set of all of their first coordinates. It's made up of 20 and 13 and 27 and 16 and 26. All numbers of hours. And the range would be the set made up of all of the second coordinates. 225 and 146.25 and 303.75 and 180 and 292.50. Those are all dollar amounts. What are the domain and the range of this function? The domain, remember, that's the set of all the first coordinates. So that would include -7 and 4 and 9 and 5 and 10. So that set of those 5 numbers is the domain. And the range consists of the numbers 1, 3, 2, we already mentioned 1, so we don't have to mention it again, and 4. So there are 4 numbers in the range, 1, 3, 2, and 4. It doesn't really matter what order you list them in, and if a number appears twice, we don't have to list it twice. Now, if you're looking at the graph of a function, the domain is the set of all of the x coordinates of all the points that make up the graph. So to see what the domain is from the graph, look at what all the x coordinates are. How far to the left and how far to the right does the graph go? And the range is the set of all the y coordinates. How far down and how far up do the points go? So on this first graph here, the domain, well, look at the points here. They have x coordinates that run from -2 over here over to +3 here. The x's take on all the numbers between -2 and +3, so that is the domain. We can write it like this, x is between -2 and 3, or we can write it like this as the closed interval from -2 to 3. So this means we're including -2 and 3 and everything in between. And then for the range, look at the y coordinates of these points. The lowest y coordinate is down here at -1, and the highest is up here at, looks like 3.5, 3.5. So that's the range. Y is between -1 and 3.5 inclusive. So from -1 to 3.5. What about the second graph here? Well, the arrows tell us that the graph keeps on going past the part we can see here. If we zoomed out, it would keep on going to the left and to the right. So the domain is really all real numbers. If we zoom out enough, we're going to see a point on the graph with every possible x coordinate. And the range, well, there's no limit to how far up we go, but there is a limit to how far down the points are. There's nothing below a y coordinate of -1. So the range is everything greater than or equal to -1, from -1 on up to infinity. What about this third graph? Can you see what the domain is? What are the x coordinates of the points that make up the graph? From how far to the left to how far on the right? Well, from -infinity to +infinity. That is all real numbers. There's a point on the graph for every possible x. And what about the range? How far down to how far up? Well, it's from -infinity up to and including 2. We have more to talk about, so I will finish this in part 2 of the video for this section.